In this statistics lesson, we'll be discussing measures of central tendency. Please feel free to press pause and read through today's objectives. In statistics, there are many ways that we can talk about the center of our data, and we call these measures of central tendency. It's just a value that represents a typical or central entry in the data. So when I look at a dot plot, it's going to be one of those dots in the middle. The most common measures of these are mean, median, and mode, and you've probably already used these before in your high school experience. The mean, which is sometimes called the average. However, I strongly recommend that you do not use the word average. Average is not a very scientific word, so we're going to stick with mean. To find the mean of the data, you are going to add up all of the data entries and then divide them by the number of entries. So in our sigma notation, the sum of the x's would be adding up all the data, and then n is representing our number of data entries. So if you're talking about a population, your mean would be the lowercase mu, which looks like a little weird looking U with like a backwards Y kind of thing. That's your mu. Mu is the sum of the x's divided by capital N. Capital N is the number of data points in your population. But if you're doing a sample, you're going to use x bar to talk about your mean. So x bar is equal to the sum of your data points divided by lowercase n, which is the number of data points in your sample. So exactly the same formula, just different notation to discuss whether you're talking about a population or you're talking about a sample. So example number 1, you are given the weight of some adults before they started a weight loss study. What is the mean weight of the adults? Okay, so first of all, this is a sample, right? We are doing a study. It's not our whole population. So we're talking about an x bar. We are not talking about a mu. So again, you're going to add up your x's and divide by lowercase n. So in this case, I have 1, 2, 3, 4, 5, 6, 7 data points. And then I'd get my calculator out and I would just add up all these very quickly and I would get 1,810. So take my calculator, divide. Again, if it doesn't come out perfect and you need to round, I always highly recommend that you round to one more decimal place than your original data. So notice our original data was all whole numbers, so our mean we should round to 1 decimal point. So that means the mean weight before starting the study, the weight loss study, is 258.6 pounds. And I'm sure you've probably done a mean problem before. All right, the median. The median is another way that you can talk about data points. You put the data in order, and then you just take the data point that is in the middle. So you're basically what you're doing with the median is you're cutting your data into 2 parts where each part has the same number of data points. If you have an odd number of data points, then the median will be one number right in the middle, and then you'll have an equal number of data points on either side. If you have an even number of data points, though, you will have the median will be the mean of the 2 middle entries. So whatever the 2 are in the middle, add them up, divide by 2, find their mean, and then that will give you the median for that data set. Because it won't actually be one of the data points, it'll be halfway in between 2 of them. So you should still have an equal number of data points on either side. All right, so again, find the median for these weights. Again, the first thing you must do is put them in order. Okay, so the smallest weight was 223. That takes care of that one. And then the next was 235. That takes care of that one. And then there's another 235. And then there's a 268. And then there's a 274. And then there's a 285, and there is a 290. So again, count 1, 2, 3, 4, 5, 6, 7. I have all 7. I have an odd number of data points. So that means I should have one right in the middle, and I do, this number right here. Notice I have 3 data points on this side and 3 data points on this side. So you should be cutting your data in half by finding that median. So the median is 268 pounds. Notice it wasn't all that different from the mean of 258.6. So you should find that these should be relatively close to each other. Sometimes they'll be very different, which then tells you some very interesting information about your data. All right, what if the adult that weighed 285 pounds decided he wasn't going to participate anymore? What would the median weight of the adults be if he decided or she decided not to be part of the study? So they're in order already. Notice at this point, we have 3 on this side and 3 on this side. So we don't have an actual number in the middle. So we would take these 2 data points in the middle and we would find their mean. So 235 plus 268, and then divide that by 2. Which if I get my calculator out is 251.5 pounds. So notice how just that one person dropping out made a huge difference in our median. All right, the last of those 3 is called the mode. This is the mode is just the data entry that occurs the most often. That's it. You could have 1 mode, you could have 2 modes, where that's called bimodal. You could have 3 modes, you could have no modes at all. Mode is very different than any other of the central tendencies, so be very careful with it. So for example, if I gave you that data set of the weights, okay, notice there's only one data point that repeats, and that's that 235. So the mode is 235 pounds. It's the only data point that repeats. So modes are very simple to find. All right, if you are given data that isn't numbers, it may be categorical. So here we went and asked people, what was your political party? Okay, what is the mode of the responses? So again, the most popular was Democrat. And again, I don't know why they're doing this, but in that particular crowd, there were more Democrats than Republicans or independents. And the I don't knows. So the mode would be Democrat. The real fun of working with the statistics is when you start comparing all of these to each other. The advantage of using the mean is that it's really reliable because it takes every data point into consideration. It's not just looking at 1 data point or 2 data points. It's looking at, you have to use every single data point to find the mean because the first step you have to do is add up all the data points. But the problem with the mean is that if you have 1 data point that's really, really large or really, really small compared to your other data, it's going to pull your mean towards that. So it's going to skew your mean. So it's great if you're just using, if you have a lot of data that's clumped together and you don't have any outliers, it's beautiful to use the mean. But there are some things like housing prices. Housing prices, I wouldn't use the mean, right? Because I have the trailer down the street and then I have the 20-acre horse farm, down the road that's on sale for $8 million. So again, you're going to have some very extreme values. So using the mean would not be a good idea. Using the median might be a more appropriate choice. So again, there's a time and a place for each of these central tendencies. All right, so here's an example where we show some ages in a class. Find the mean, the median, and the mode, and then are there any outliers? And then talk about which one is best. All right, so you'd go through the process. Let's start with the mean. All right, so the mean, remember, you're just going to add them all up. So if I add up, let's see, first of all, how many students are in this class? 1, 2, 3, 4, 5, 6, 7. 7 times 2 is 14, 15, 16, 17, 18, 19, 20. All right, I've got 20 students in my class. Add up all their ages, which I didn't even write that down. That was not a good idea. But then whatever it is, I divided it by 20, and I got 23.8 years. Okay, which kind of makes sense. Most of the students were in their lower 20s. But notice that one outlier of 65 probably pulled that mean up a little bit more than it needed to be. So if that person wasn't in the course, it might be a very different result. All right, what is the median? Okay, again, we've got 20 data points, so there's going to be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right in between those two is where my median should be. I've got 10 data points below it and 10 above it. So I got to add those up and divide by 2. And that gives me 21.5 years. Again, not too far off from our mean. And then let's look at our mode. What is the age that shows up the most? And that would be 20 years old. I got a lot of 20-year-olds in this class. So 20 years is my mode. All right, so let's compare all 3 of these. Okay, they're all pretty close to each other, right? They're 23.8, 21.5, and 20. all very close. But again, that mean is really being affected by that 65-year-old in the class, whereas that 65-year-old really doesn't affect the median all that much. And then the mode, well, the mode is just the mode. Like, I just happen to have a lot of 20-year-olds. So it doesn't say that mode is not going to reflect the accurate age. Like, if you call a 24-year-old a 20-year-old, they might get upset. If you call the 65-year-old a 20-year-old, they'd be probably very happy. So again, you have to think about what makes the most sense for the situation that you're dealing with. If we looked at a histogram of this data, or a frequency histogram, you can really see how that 65-year-old is that big outlier. Here's most of our data, and then we've got that one outlier out there. That huge gap really tells me that median's probably the best thing that I should look at for this data. Another mean that you can find is called a weighted mean, and all of you probably have experience in this, you just didn't know it. When you find GPAs, you are finding a weighted mean. In order to find a weighted mean, what you will have to do is you will have to add up all of the weights of each entry, and we will talk about what that means in our next example, and then divide that by the total number of weights. So I think GPA is probably the best way to talk about it, just because it's something that you've worked with it before and it will be familiar. So here are your semester grades from last semester. We're just going to pretend. The grading system is as follows, that an A is 4 points, a B is 3 points, a C is 2 points, a D is 1 point, and an F is 0 points. These are usually called quality points. So when you want to find your weighted mean, okay, you are going to have to add up your quality points. So each of these final grades has a quality point. So C's are 2, this is 2, this is 2, a D is 1, an A is 4, a C is 2, a B is 3. So that is those are your weights. Wait, no, your credit hours are your weights. There we go. Those are your X's. My grades are my X's. The credit hours are my weights. So I'm going to add up the sum of my X's times my Y's, and then I'm going to divide that by my total number of credit hours that I took this semester. So the credit hours is probably the easiest, right? Because that's just 16. I can add those up real quick. So you may need to make an extra column on your chart, right, where you do your X times your Y's. So 2 times 3 is 6, 2 times 4 is 8, 1 times 1 is 1, 4 times 3 is 12, 2 times 2 is 4, 3 times 3 is 9. And then add up those quality points that you have earned. So you have earned a total of 40 quality points based on your semester grades and the credit hours that each class is worth. And obviously, if you get a C in a 4-credit class, it's going to count more, right? It counted for 8 points, whereas if you got a C in a 3-credit class, it only counts for 6 points, which kind of makes sense if you think about it. All right, so that was 40. So if I take that 40 and divide it by 16, I get my GPA. GPA should always be rounded to 2 decimal points, just as a general practice across all the colleges and universities. So your GPA for that semester was a 2.5. So that's how you calculate your GPA. Very simple. All right, here's another example. All right, here's you took a math class, English class, biology, and racquetball. There's the credits, there's your letter grade. And they even told you the quality points. So that's what that numeric grade is. So those are the quality points that you have accrued for each one. All right, so let's find your GPA. All right, so your GPA, again, is going to be the sum of your weights times your X's. So your letter grade, these are your X's, and then your credits are your weights. So how many credits did I take this semester? I took 4, 8, 9, 10, 11, 12. I took 12 credits. And then I'm going to divide that by so again, you might need another column. Don't be afraid to make another column over here. 4 times 4 is 16. 4 times 3 is 12. 3 times 3.7 is 9, 10, 11.1. And then 1 times 3.33 is this. I would add those all up and then take whatever that number is and divide it by 12, which of course I didn't write this down, which was not very smart. But either way, that comes out to 3.56 when you round it to 2 decimal spots. So that is your GPA for the semester, for that particular semester. So again, I think weighted means are just something once you've gotten used to them, they seem really intuitive. All right, you can also find the mean of a frequency distribution. So what if they don't give you the data? What if they just give you a frequency distribution, but you don't have the original data? You can approximate it. You can't find it exactly, but again, you can approximate it using this formula right here, where you're going to take the sum of your x's times the frequency, so data points times frequency, multiply each of them, add them all up, and then divide by n. And that will give you, and the x's, since we don't have the data points, you would use the midpoints, right? So the midpoints are your x's and the frequencies are your f's. So you have to make sure that you have your midpoints. All right, so if I were doing this, number one, the first thing you'd have to do is you have to find the midpoint of each class. So you would do that first, and we talked about that in a previous lesson. Then you'd have to find the sum of the midpoints times the frequencies. So I'd make a separate column, take x times f for each class, each midpoint times frequency for each class, and then add those all together. And then find your n, which should be the sum of your frequencies, and then divide those two things. So here's my first example. Okay, this shows the cell phone screen time for those 30 adults, which we talked about this data in a previous lesson. Okay, so there's my class midpoints and there's my frequencies. I would like you to approximate the mean based on this data. So first thing I'm going to do is I'm going to write down my formula. Anytime you're doing any of these problems, you should definitely write down the formulas first. All right, so I need to find the n's. So first of all, there's my n's. I'm going to add all these up. And again, that should be the 30 people that you talked about, right? They even told you in the problem. So my n is 30. And then I need to find the sum of the x times f's. So I'm going to make another column on this, and I'm going to call that x times f. So I'm going to multiply each of these things. Again, I won't do that in the interest of time for this video, but you can sit down and do that. Multiply each one, and then when you are done multiplying each midpoint times the frequency, add them all together, and you should get 8631. So I'm going to take 8631 and divide it by 30. And when you do that, it does come out very nicely. It comes out to 287.7. So that is my approximate mean for this data. Again, I don't have the actual data, I just had the frequency distribution to do this off of. So again, you can even use mean in cases like this, so you can approximate the mean. But once you start putting all of these central tendencies together with the graphs is when life gets pretty interesting. So if your data is symmetric, so if your histogram looks like a beautiful upside down bell, looks like a beautiful little mountain peak, right? It's perfectly symmetrical. Your mean, your median, and your mode will all be exactly the same thing, and they'll be right in the middle. And this is what we hope for. And if you have large data sets, you can usually get a symmetric distribution. But there are other types of distribution that are equally as valid. It's just we will be spending a lot of time talking about the symmetric distribution in our statistics class. You can have uniform distributions where every data point has the same frequency or the same relative frequency. So notice here, no matter what number I choose, there's 20 of them. Okay. This one, the mean and the median are exactly the same thing. It doesn't have a mode because all of them have exactly the same number of, right? They're all 20. So they all have the same frequency. So there is no mode in this case, but that is called a uniform distribution. It looks like a rectangle. And then you will see some skewed data points. So this is called a skew to the left. It's negatively skewed because that is where the tail is. The tail is on the left. So when you talk about the skew, it's always about the tail. The tail is on the left. So notice most of our data is shifted off to the right over here. And notice the order. The mean will be the lowest value, the median would be next, and then the mode. The mode and the median might change places, but the mean would always be the smaller one, the farthest one to the left. So mean would be first, then median, then mode. Or mode than median, depending on the data. But that's what your shift is, which means these down here are pulling your mean closer to the left end, right? So the mean is skewed to the left, the direction of the tail. Same thing goes if you have a right skew. Okay, so if you have a right skew, your tail is off to the right, which means your mean is going to get pulled to the right. So the order from left to right would be mode, median, mean, or median, mode, mean. But the mean will always be the one farthest to the right because that's where the tail is. That's where that's being pulled towards those numbers. So that's called a right skew. All right, so as an example, if I gave you these two and I didn't tell you what was what, tell me where the mean's going to be. All right, so let's look at the one on the left. We have got A, B, and C. Okay, which one is the mean? Okay, I always start with that one because the mean is the closest to the tail. So my tail is on the right, so that means C would have to be my mean. So C would be my mean. Okay, and A and B, it would depend on the data. But usually the mode would be the farthest one to the left, and then the median would be the one in the middle, usually. All right, and then let's look at X, Y, and Z. Again, this one is skewed as well. Notice my tail is to the left. So that means the X would be my mean because the mean is going to get pulled towards the tail. And then your Y and your Z, again, depends on the problem, but mode will usually be the Z and median will usually be in the middle. Again, like the median in the highway, the median's usually in the middle. So that's a way to look at mean, median, and mode when you're talking about the distribution of data when you're looking at the histograms that go with these frequency distributions. All right, so go take some time and practice. Again, get really good with your calculator because you're going to need it. And we will see you for the next lesson.